Today's lesson is a part 2 on ionic compounds. The difference here is we're going to be talking about ionic compounds that do contain transition metals. Transition metals, unlike elements in the S and P block, do not have predictable preferred charges. Instead, their charges have to be calculated based on the formula, or they're given to you by the name. In this case, you have to know one or the other in order to get the other one. You cannot arrive at the formula without the name. Let's start with being given the formula and being asked for the name. CuO. Based on my previous ionic compounds video, copper is positive, so copper will get its name. Oxygen is negative, so it's going to get that IDE ending. And the difference with transition metals is that between these two, there's going to be a Roman numeral that signifies the charge of the metal. We're going to have to do some math to figure out what that is. Oxygen is in family 6A. It has a preferred charge of -2. That means that the total negative charge is -2 because there's only one negative thing. That means that my total positive charge is +2. And there's only one positive thing, so its charge must be 2. Now, copper does not have to be copper 2. Right? If this formula were to look different, if it were to look like this, then the skeleton of the name remains the same, but we're going to have to recalculate what that Roman numeral is. Oxygen is still oxygen, it's still -2. It's still the only negative thing, so the total negative is -2. That means my total positive is +2. In this case, however, I have 2 positive atoms, so each one is going to be +1. Now, what happens if instead you are given the name and asked to work backwards to try to find the formula? Well, in order to do that, let's try an example. Chromium 6 oxide. So chromium 6 oxide, I know that my formula is going to have a Cr and it's going to have an O. And I need to figure out what the numbers are here to figure out my formula. Well, I know that oxide, oxygen, is always -2. And in this case, chromium, they've told me, is +6. So I have a problem. I have +6 minus 2 is equal +4. I need all of these charges to add to 0 in an ionic compound. So what can I do? I can give myself 3 oxygens. If I do that, then all my charges add to 0, and I know that this must be the correct formula. CrO3. Chromium does not have to be chromium 6, however. What happens if we were given a different name? What happens if this was chromium 3? If this was chromium 3, then we're going to start in much the same way. I know there will be a Cr, and I know that there will be an O. But I am missing how many of each chromium and each oxygen I have. I'm going to have to start thinking about some math here. Oxygen is always -2. And in this case, they told me that chromium is +3. Unfortunately, these numbers are not multiples of each other. So we're going to have to figure out what the least common multiple is between 3 and 2. In this case, it's 6. So I need to get my positive charge to add to 6, and my negative charge to add to 6. How do I do that? Well, I can do that by having 2 chromiums and 3 oxygens. So, the final formula for a compound named chromium 3 oxide would be Cr2O3.